So on this next one, I want to find the slope at a particular point. So that means I need to take the derivative. Now, I actually have a couple of options, so I'm going to work this two different ways. I could do explicitly. Remember, explicitly means I need to have y solved for itself. But I could do that in this. I could get y equals 4 over x. And so then when I take the derivative, I'm using quotient rule, which is low d high minus high d low all over low squared. So that's really just going to be negative 4 over x squared. And since I want to know the slope at a particular point, I would plug in the x value because the slope is dependent upon the x value. That's what it says. Slope needs an x value in order to calculate it. So the slope would be negative 4 over negative 4 squared. So negative 4/16 or negative 1/4. Okay, so now let's see what happens if I do this implicitly. Let's say I forget that I can get y by itself, or I just love doing implicit differentiation. It could happen. So I have a product rule, so I have to do first times derivative of the second, but the derivative of the second is just going to be dy dx, excuse me, when I power it down, plus second times derivative of the first, which is dx dx, but of course that turns into a 1 equals 0 because the derivative of 4 is 0. And so now when I solve and I get the dy dx by itself, well, let's see, first I would want to subtract y from both sides. So I'll have x times dy dx equals negative y, and then I would divide both sides by x. So dy dx equals negative y over x. And now since the slope is dependent upon both of them, I substitute in both numbers. So a negative 1 over a negative 4. And oh my gosh, look at that. It's equal to the same value. So it works either way. Pretty cool, huh? So on this next one, I've got to find the second derivative, and that's what the little squares tell me. So again, I can't really get y by itself, so I'm going to stick with implicit differentiation. So for first derivative, I'll have to start with that. I'm going to power down, so I'll have 2x, and then it would be dx dx, but of course that's equal to 1, so I don't really need to write that. And then minus, power down the y, but that'll be 2y dy dx, because that variable doesn't match, equals 0. And then if I get dy dx by itself, I'll move some things algebraically. Whoops. So my first derivative is equal to x over y. So now I'm ready to find second derivative. So now I have to use the first derivative and take the derivative of it. Whoops, forgot my little squares. And since this is a quotient, I'll have to do quotient rule. So I'm doing low d high, but derivative of the high is going to be 1, so I'm going to erase that, minus high d low all over low squared. So now the question is, because I'd like to simplify this down as much as possible, do I know anything in this particular formula? And the answer is actually I do. I know this because I just solved for it. Because that came from up here. And so then I can simplify the numerator. Of course, that's going to take a common denominator to make that work on top. Oh, I don't know how that... Okay, I made a correction. I accidentally rewritten that as an x. So now I have y squared minus x squared